Alright, I'm going to do one final example for you today, and that's example 8. I chose that one because it's another one that has kind of that scary looking square root. This time it's a 4 root 2. Plus it's a problem that uses foci and covertices, and we haven't done any that involved that combination of information to begin with. So I thought it'd be a nice one to wrap up our examples for the day. I will try it one more time without a graph. But again, if you prefer the graphing method, I encourage you to pause the video, make a quick sketch, and see if you can come up with the center, because that's the first thing that you're going to always want to find. So in trying to figure out the center, I want to look for where I see some repetition. So I see some repetition of a -8. I also happen to see that that -8 is here, so that makes me feel pretty decent. It's always in the y-coordinate, so I'm feeling pretty solid that my center might involve a y-coordinate of -8. Then I want to look for any repetition on the x, and I see that I have a -3 and a -3. So again, what's kind of nice, if you're paying attention, is that within the foci, depending, when they're these scary looking foci, you'll actually notice that both the x and the y coordinate can be seen from the foci when it's this messy version. So you can see that -3 and -8 are our center. So once you have your center, keep in mind that you can start the equation process. So you can change those coordinates, make sure that you're adding the two components together, and that you're setting the equation equal to 1. Sometimes people forget the equal 1. Now the next thing that I would do is start to identify anything I can in terms of A, B, or C. So what I know is with a focus that that's connected to my C value. So if I'm going to go from -8 up 4 root 2 or -8 down 4 root 2, clearly the movement is 4 root 2 that I'm going to need to square. But I want to remember that since I'm talking about covertices, covertices are connected to the B. So if this distance between between 4 and -10 is a span of 14, that means that I've moved 7, because 7 is half of that span, so the distance from the center to one of those. That's another way to think about it. So if I did 4 and I subtracted 7, I'd be at -3. Or if I did -10 plus 7, I'd be at -3, which in both cases kind of confirms what I was already thinking. So it means I don't know my a squared because I don't know anything about the vertices, but I do know the covertices. So I can make sure that I manipulate that appropriately. So 4 root 2 squared is 32, and my 7 squared is 49. When I bring those together and finish solving that equation, I get a squared. And again, I can stop at the a squared portion because I don't need to know what a is to write the equation. You do notice that I started to put that 81 in the wrong spot though. So one of the advantages to the graph is remembering that the foci go the same direction as the graph does. So this is a vertical movement to change to your y-coordinate, which means that that 81 for the a should be underneath the y. So you just want to be careful with that, and again, that's personally why Ms. Olson prefers the graph portion. So x plus 3 squared over 49 plus y plus 8 squared over 81 equals 1 is our final sample problem for the day. I wish you luck in going through the homework. Please reach out a little bit more than you did last week so we can keep you on track and make sure that the questions that you have are getting answered. There's no reason to struggle when Ms. Olson is sitting by her computer at all moments of the day trying to get as many questions answered as are asked. And she really would enjoy answering even more, or putting together more videos, or putting together a hangout, whatever it is you guys need. Just reach out to her and let her know so that she can meet your needs as much as possible. Wishing you all health and wellness, and miss you so much. Take care, guys.